was the first flight path. The next one, I'm just going to add a plane, and this will become my second flight path. Now this time around, I want to be able to control precise number of rockets to go from source A to source B, or A to B, whichever. I could do it backwards if I really wanted to. But so I'm going to hide this first one so we don't have to look at it, and I'm going to do this one, create a fresh set of geometry nodes. If you're not in the layout, just go across the geometry node tab, and here we are. Alright, so we need to be able to record some useful information about our start point and our end point. So we're going to need to actually grab these again, so I'm going to drop them in here, source, target, and I'll need the missile object later on. Alright, so just like before, using a Bezier, but we need to set up an array of points for our starting locations. Okay, add, Shift A, S, points. Great. We give it a position. I'm going to duplicate that. Alright, so now we have a set of points. We have two sets of points. We need to combine them into a Bezier curve. I'm going to start with just purely the first one because this is sort of how I worked it out, but yeah. So adding the Bezier segment again, I'm just going to zero as many values as possible in that lot. Keep the resolution at 10 and give that a instance on points. I'll add instances on points. I'm taking this as my instance and these as my points. So we should be able to connect this up to the final version and see a curve. And we have a whole pile of curves stuck in the middle here. Not particularly useful yet, but we need to vary the endpoint. So, and this is sort of, I suppose, how I've worked it out, but I need to realize the instances so I can manipulate those endpoints. And then I'll need to set position of the endpoints. Now, in selecting those from my index set, I'll only need to grab the endpoints, but I'll need to actually resample sample these at various parts. So I'll have to sample this index, that one. Now what do I need to sample? I need to sample a vector point, and it has to be the position of those points, and I'll need to find the index. Now I'm suspicious that I'll only need to find every second index out of this list. Divide, maths node, drop it in there and have a divide by 2. This will give me a whole bunch of endpoints to work with, and then I can drop that into the set position in here. Now but I still need to actually select the appropriate points, and that will be a modulo, if I can actually type modulo, taking the index value. So here I'm just selecting every second point in my list, and we can see we've got this resolved now. We have two controls for the number of points that actually need to be the same number, so this needs to be an integer, just so I can have control over how many points I've got. That one, grab that and drop that in there. So here I can increase the number of points, but they're all in the same location. If we've got 2 or 3 lines, they all form the same line. A bit frustrating, that one. So we need to space those out to actually give them a bit of randomness. So here I'm going to basically take the location and add a random value to it. So we go random value, which of course will be a vector. It has a min and a max. Now from memory, yeah, I did from -1 all the way through to 1 in each direction, so it'll float somewhere around that point. I've got a seed value, so I now just need to combine them basically. So if I add this to this one, oops, plug that into there and add that into there, I get an array of points. So I've got 4 vertices here, and it's basically repeat that same structure for the bottom. So grab this, duplicate, drop down to there, and grab this thing and take that location and just shuffle it about a bit. So yeah, plug the seeds in if we need to, but I have to admit I didn't really bother, because the straight lines kind of work in favour of getting them to spread apart and come back together again. So that actual spreading apart and coming together. So once I've got this, I've got a set of curves. I need to make them, I suppose, space out and slide together, and also need to add in that, yeah. So with a set handle position, I can drop in a bit of chaos onto this end position, or scale it up, I suppose, so that it looks like the missiles are actually sweeping in. So here it's just a bit of vector maths. In this case, it's only going to be scale. Whoops, it's bottom of the list. Scale. And so here I can rescale my offset, and that will grab that left handle of one of the points and move them. So to do this, I'm going to need a vector value. Again, another bit of randomness. So I'm going to grab that from over there, duplicate, bring it here, plug that into randomness, and hopefully get a little bit of twisting. And here we have a control, so we can make it space a bit more. And so they're all sort of sweeping in towards their target. The same can be done for the other end. So if I duplicate that one and I hit the right handle, and then duplicate this set, again, a bit of offset, it can get a few more interesting shapes. I suspect that the scaling on the initial value, you kind of want it mostly going forward. So something like that, but it does lead to some interesting patterns. So this way I've got some precise controls to scale up a number of things in an exact number, which is what I was after. And now I just need to tidy up this into a node group so that I can then use it down the track to actually animate on. Because this gives me the set of curves. So we have a set of points. We have the initial object, the next object. Did I add a missile? I thought no. Oh, didn't need it. Oh, that comes into after the group. I'll leave it there for when I've actually assembled the group, so that comes later. So anything that's a constant, I can then sort of look at tweaking. Now, I'm just going to duplicate my input group, bring it down here, because I would like to be able to control the how far apart the missiles spread, and a bit of a seed number as well. So yeah. So here I'm looking at spread. Yeah, if I can actually spell it correctly. And then the seed is the missile seed. What else should be recorded? I think that's about it, really. We've got source, we've got target. So that's the source. Then the target object. Alright, and that gives us a node group to work with. So if I go Control G, that's all now a single node group that's reasonably set up, or at least it was until I renamed everything. Alright, input is it's an integer, and that is missiles, number of missiles. We have, this one should be below that one, so yep, that's my target. Target, source, the scale, which was down here. No, let's just put it all up here. Alright, scale is the missile scale, so it's missile scale, and then finally the missile seed. And this is the I suppose the core part of actually getting the node group to do what I needed to do. This gives me lines to then animate along. Now I need to actually add the animation part. I'm gonna actually have to start tearing this stuff apart so I can actually track one missile along each individual curve. So if I can't remember why I trimmed curve in this part. Must have been a reason for it. But curve 2 points, and I only need 2 points, the start and the end of that curve. So here I'm just trimming the curve to whatever it is. Oh yeah, that's to grab the start point. So where it is along its flight path. That makes sense now. So I've got 2 points and I need to grab some information of them and then instance on those points the various missiles. So AS instance on points, that one, great. So I have a list of points. If I add the geometry to here, I get a whole bunch of things at each end. It's not what I wanted. So for this, I'm going to need an index node. So index. I'm going to need to do the standard trick of using a maths node with modulo 2. Where's modulo? There. To pick out every second point, and you'll encounter the error in just a moment. We have them at our endpoint, not at the start point, but we want them at the start point. So here's where we just pull out a little, add another maths node to basically just add one. So here, all it does is, yeah, takes that first point. So this identifies the start point of where they should sit. So as I trim this, they move towards their destination. I'm pretty happy with that. Now, that's my missile. That's this. We need to get them to actually match the curve. Now this becomes add an align Euler to vector. And we need to basically adjust the rotation to suit. Great, they're pointing the wrong way. Isn't this wonderful? Now, we have the rotation here, which will give us the rotation of these, and they go a bit weird, but if we then plug in the tangent, they're still weird. And then, let's have a look how they flow. Ah, yeah. For some bizarre reason, right at the very start and the very end, the animation glitches out. So I really, for the start point, I want it to be, you know, 0.001, not even that much, like a lot less. So let's add a bunch of zeros to this. No, not enough zeros, too many zeros. So from 0.1 all the way through to that, take away 0.01. 99, let's go 98. See how they're flying. Well, I'm not overly concerned about how they end as long as they get to the... No, that's probably too much. So I need to bound these within a reasonable number. So this is where the map range comes in. Map range. And I want to take it, whatever value, this is my animation base, from 0 to 1, but from a minimum of 0.01 to... Probably let's go 0.098, 97 maybe. And if I plug this into my start point, and if I look at the value, it goes from 1. So if I do this from 0, negatives are not relevant, to 1, yep, to there. I could even possibly push that, no, not that much, 0.98, yep. So here, it just, yeah, that last little bit's a bit problematical, so I'll just do that. It'd also be good to actually visualize these flight paths as they're going, so I will join the geometry of what I've just created and the original flight path. So drag that over there, plug that in, if it'll let me. There, done. and add a reroute node just down here. So this allows me to track the actual amount of missileness. Now the great thing is I need to plug this into here, so I've got my missile spread, I've got my missile target still for a very bad day. Far too many, needs to be almost like a weird nuclear thing, and then they all sweep in towards the end. Now they all move with a consistent distance, and I'm not completely happy with that, so what I want to do is add in a bit of random noise to their start point and their end point. So instead of going straight for the map range node, what I want to plug into it in terms of my animation value is a bit of noise, a bit of randomness. Now you could use a noise texture, but I find that let's see, a random value between 0 and 1 sounds pretty good. Then maths that so that we add in our animation frame into here. So here, and that into there. So they're already a small amount ahead. Now, there's two ways we can do this. Either, and you can see here they're all at different parts of the cycle, but in general, at the start of the animation, so when it's at 0, I want most things to be roughly around that area. So this is not doing it for me, but with a multiply add, if I add the animation to a bit of a fudge factor, so I found that minus 0.1 to this random noise value gives me not bad results. They all start at roughly the same time and they all end at roughly the same time. And that gives, I mean, there's far too many missiles here for now, but you can see that's a sort of rough setup. So here, randomized. Now we want the seeds to be a little variable. Does it need to be variable? So I just cheated and added the index in here. So each one will have a random seed and they all roughly follow that path. So they have a slightly different starting time. So J here, random start time, and then and this is basically my animation driver. Curve. Oops, I'll just grab that. Yep, that's better. And then I can start clustering these up. So this is basically aligning to path. This lot is adding the missiles. So now this join geometry thing, I kind of think probably want to be able to turn that off and get rid of it. Delete geometry. Great, so that just deletes the paths, and I want a control to turn that on or off. That's a simple Boolean value, so I should be able to just plug that in there and it gives me a little tick box. Done. So, naming this animate, and then show paths. Whoops. Oh no. Hide paths. Tick. Yep. And I just use the show paths for basically debugging purposes, so I can work out what's going on. Building on this, we need to then define the smoke trails that follow these rockets as they jet about doing their thing. So first off, I suppose I'm going to need to, like I did here, and Alt-P, define the start of the rocket, but I also need to shift it back a little bit because we don't want it going on forever. All right, so we have that. I need a curve, which will be this thing. So this is the curve that we're following. Just group all those so they look a little neater. Then I will need to know a delay and how long my smoke will be. And I need to base this on this animation time. That's my start time, but it will affect my end time. So in here, I need to, I'll add the maths node so I can get the logic happening and show you what I'm wanting to do. So here I want a subtract some amount. Let's go 0.1, and this will become the length of my smoke, whatever it is. So I want to be able to put that value into there as well. This is actually, I think, doing it backwards, whereas this will be the end of that, and then there's this little delay to make it stretch back a bit. But we'll see what we can visualize in just a sec. So once I've done this, resample curve, I don't think I even bothered changing the values. Set curve radius, so I know how big it's going to be. We'll get some stuff affecting that in a moment. And then we need to take that curve and convert it to a mesh. And then we actually also want to add a profile to that curve. So curve circle. All right, so we plug in the curve circle, fill the caps just to make it neater. And we could assign a material to it, but I want to have a look at it, what it is just now. So here we have this dotted line coming out the back. Not particularly awe-inspiring in terms of rocket fuel. I want to take basically the spline parameters. In this case, I'm looking at the factor from go to woe. And I want to plug that into the radius here. So if I plug it in as a factor, you can see, well, yep, there's this sort of cone shape. Great. And I could almost say done, but I might just add a map range in case I want to tweak this value somewhat. So, in fact, in my example here, I haven't even bothered using it. Yeah, that's fine. Resample curve. That should be enough for a jet engine. The resolution I dropped to 8 because how much detail is actually needed in these curves to give the rocket stuff, but you could, again, make it as large as you want. Smoke. Join smoke trails. And what I have here is this control of this number to make them longer or shorter as I choose. So this smoke length, this subtracted number, and I'm just going to duplicate my input nodes up here so I can start plugging more stuff in. So this is smoke length, the basic setup, so I can actually set material and add a bit of a translucent sort of smoke. I have the default material and I can make it somewhat see-through and all that sort of stuff in the materials thing, but I'm really focusing on the nodes and not on the geometry nodes and not the material stuff at this point. This is the entire setup for the smoke trails, adding the missiles, the instances, joining everything together, and that allows me to hide and reveal the trails as I see fit. So here, hide paths or reveal, either or. So yeah, this is my experimentation with Flightpaths. I'm not too sure how long I've been talking now, but it seems like a long time. I hope you enjoyed it, and yeah, next time.